for our discussion this afternoon, our topic for today is statistics at work in the real world. So, what I did, I've selected the topic in statistics that can be applied in mathematics in the real world that is mostly being used by all courses and all industry. So, this is the most common that they normally use. And since we are scattered here. Like we have civil, we have IT, we have legal management. So that's why I selected this one because this is not just applied in the real world. It's also applied in all industries. So even business management can use this one. So regression analysis is being used by most industry if they are going to compare the relationship of one or more variables with each other. So normally we have one independent variable being compared the effect of that independent variable to a dependent variable and vice versa. Also, it also uses to actually determine the effect of an independent variable to another independent variable. Okay, so let's move on. Let's move forward. So the definition of regression analysis is it is a technique of studying the dependence of one variable called dependent variable on one or more variables called explanatory variable with a view to estimate or predict the average value of the dependent variables in terms of the known or fixed values of the independent variable. So in that case, let's say for example, you are actually forecasting let's go to civil engineering. For example, you are forecasting the effects of the quantity of a certain material used for building a house if there is an effect to the quantity and the pricing because that's how they normally do the costing. They have to check if there is an effect with the pricing and the quantity needs to be used on a certain project. So the regression analysis can be used to actually predict if ever that we have proven the relationship between the two, can we get the value of a certain material, like the price of that certain material, if we are given the quantity and the pricing. So we can check whether we could get that value so we can derive a formula for us to be able to get that, but it's actually time consuming to be able to do that. So since we are using it in the real world, we are going to use an aid which is the most common one, which is Excel. SPSS can be used, but for offices purposes, so we can actually use the best one, which is the most available in different offices, which is Microsoft Excel. So normally the regression technique is primarily used to number one, estimate the relationship that exists on the average between the dependent variable and the explanatory variable. Then the second one is to determine the effect of each of the explanatory variables on the dependent variable, controlling the effects of all other explanatory variables. And then predict the value of dependent variable for a given value of the explanatory variable. So, what are the assumptions of the linear regression model? So, we have linear functional form, we have fixed independent variables, we have independent observations, we have representative sample and proper specification model. no omitted variables. So normality of the residuals or errors, equality of variance of the errors like homogeneity of residual variances, no multicollinearity, no autocorrelation of the errors, and no outlier distortion. So regression analysis is the most often applied technique of statistical analysis and modeling. Normally, it's being used for to prove a certain objective or hypothesis in a certain study, not just um, in in a specific course, but all courses, as long as you are proving the relationship of a certain variable. So normally, another example that we can use this regression analysis if we are going to do some questionnaires. So if you are into surveys, so for us to be able to, to determine the relationship of the different questions on the questionnaire on the topic, we can actually use regression analysis for us to be able to identify which questions there needs to stay on the questionnaire that will prove your objective. Also, it can also be used to actually omit the questions that has no relationship at all to the study. So you can replace it with the best questions that will suit your study. So if two variables are involved, the variables that is the basis of the estimation is conventionally called independent variable, and the variable whose value is to be estimated plus is called the dependent variable. So that means that the independent variable, the value is staying the same, but the dependent variable is moving depending on the value of the independent variable. So meaning to say, if we add a value to the independent variable, if the relationship is positive, the dependent variable should also go up a certain value depending on the result of the regression analysis. But if it's negative, the dependent variable will go down the value depending on the result. So later on, you will see that on our succeeding activities. So in general, it is used to model a response variable, y. So it represents y as a function of one or more driver variables. So we can tag this x sub 1, x sub 2, x sub 3. So the functional form to be used for the equation is y sub I, since we only have one y, since it's a dependent variable, is equals to, this is the coefficient or the values, plus, so the constant sub 1 multiplied by the coefficient sub 1 plus the second constant. So we will tag this as sub 2. So second constant represent the constant of the second variable multiplied by the coefficient. The coefficient will be computed after the result will be presented. So the value of the coefficient here on the first variable will also be dependent on the coefficient on the result. So plus and so on and so forth, depending on the number of variables involved. So I've represented the constant as sub p and the coefficient as sub pi because we don't know how many variables we are including. It's depending on your study and the purpose. Plus the coefficient of the variable. So all of these values will be dependent on how many dependent or independent variables will be involved on your computation. So the dependent variable is variously known as explained variables, predicted response, and endogenous variables. So depending on your studies, for example, you are actually reading a certain study related to civil engineering or legal management, sometimes you will observe There is no dependent variable, but you will see the predictant variable. That's also called the dependent variable. So don't be confused with that. If you see response, endogenous, and predictant, that also considered as a dependent variable or explained variables. So don't be confused about the terms. While the independent variable, sometimes you will see it as explanatory variable or regressor variable and exogenous variable. If you don't see the word independent and you see one of this, that means that that variable is independent. So this is how normally the intercept was derived. So based on the formula that we have earlier, so y is equals to a constant, first constant, plus b, second constant, multiplied by the coefficient of x plus e, which is the third constant. So e is equals to y minus a minus b multiplied by x if we are going to change it. So if you move e to the other side, it will be negative e. Then if you move this y to the to the other side, it will be negative y. So since we cannot have a negative expression on the left side, we have to multiply both sides by negative 1. So the sign of the one located on the right side would change after multiplying it to negative 1. That's why you have negative a here and negative b here and positive y here since we multiply them by negative 1. So summation I is equals to E summation N I is equals to I summation of Y then minus summation of A minus summation of B multiplied by X. So by definition, summation of E based on this formula is always equals to 0. Then we can actually conclude that 0 minus summation of A minus summation of B is equals to summation of y based on this formula on the upper part. So we can also consider the value a is equals to summation of y minus b multiplied by summation of x since the coefficient should be located on x. Later you will understand right after we do it in Excel um, what are the summations are for. But don't worry, I won't let you compute this one. I just showed you how the different formula is derived because later you are going to identify a certain formula. So the term E in the model is referred to as a random error term and may reflect a number of things, including the general idea that the knowledge of the driver variables will not ordinarily lead to perfect reconstruction of the response. So if there is only one driver variable, which is the independent variable x, then we usually speak of simple linear regression analysis. So when the model involves multiple driver variables, a driver variable in multiple forms, or a mixture of either dependent or independent variable, we speak of multiple linear regression analysis. That's why in Excel, you will see linear regression and we have multiple regression analysis. So the linear portion of the terminology normally refers to the response variable being expressed as a linear combination of the driver variables. So in regression analysis, the data used to describe the relationship between the variables are primarily measured on interval scale. The chief advantage of using the interval level of measurement is that using that such data, it is possible to describe the relationship between the variables included on your included on your study. Hence, we can actually derive a mathematical equation that we can use to get the succeeding values of the numbers on a certain table. Let's say for example, we go back to our example earlier. So we have quantity of the materials, and then we have the pricing, and um, we have the pricing. So if we are going to compare the pricing and the quantity given the initial data, we can compute the value of the quantity using the price and vice versa, depending on the result of the regression analysis. So if we prove that they have a strong relationship, that means that we can use that certain table, which is the quantity, to get the price. We can also use the price to get the quantity and vice versa. So this in turn allows more accurate prediction of one variable from from the knowledge of the other variables, which is one of the most important objectives. That's why we need to use a regression analysis. So it is also important to note that if the relationship between x and y is curvilinear, the regression line will be a curved line rather than a straight line. So the greater the strength of the relationship between the x and y, the better would be the prediction. So if there is no relationship at all, we cannot do a prediction. We cannot use that certain value to get the exceeding value of a certain variable. So we should have a good strength on the result. So the problem is presented to the mathematician as follows. So the values of a and b. So if we have a variable a and b in a linear model, so we can then conclude that we can represent that the coefficient of A is y, and then the coefficient of B is actually x. Then we can conclude that y is equals to the constant of the coefficient y plus B, which is the constant of the coefficient x. So whatever the value of the coefficient x, you can multiply it with B and add it to the constant of A to get the value of y, which is the y-intercept. So if we are going to use that formula, we can actually use this. So using a similar procedure to find the value of A yields then A is equals to summation of y minus the constant of x multiplied by the summation of y. So this is what you are going to apply if you are going to use the regression analysis. So let's say for example, if you're going to predict the value of the pricing, then you need to use this formula after getting the y-intercept and the coefficient of x. And then you need to use the existing values on the data. Yes.